Well, that was fantastic. I really enjoyed, I think we touched on a lot of some very important topics there. And I liked the way the talks kind of overlapped and touched on similar themes. It was really, really interesting. I think, and it's not an easy project. This is not an easy initiative or problem to solve, that's for sure. It kind of goes against, in some ways, some of the way we've been trained to focus on optimizing and being very specific in what we do, specific breeding targets. That challenge between a specific breeding target and a broad set of targets it goes a little bit counter to some of maybe how we were, at least how we think in a commercial breeding program for sure. And we have to sort of step back and think about things differently. So. All right, so let's open it up for some questions from the audience. We've got at least one, to start things off here in the center. We've got microphones. Where are the microphones?
Our mics are all on the table, so people are going to have to speak.
Oh, okay. All right, I didn't realize that. Maybe we could donate one microphone. You guys can share. Does it have to be turned on? There we go.
All right. So, Alan, that's a really great setup, I think, for the topic, and a nice overlap. You talk about breeding system, but I think you touched a lot on this. It has to be, where's the value chain? Like, for example, you can create all these crops. Do you have the crushers? Do you have the market? In the end, does it make sense for everybody along the value chain? So I just, maybe you can comment on that. You really need to set up and make sure there's an end market, if you want to call it, and the critical infrastructures there, right? So I'd like to, we need to think well beyond breeding, I think, for there to be any sort of value to this along the way, if people can comment on that.
Yeah, I would absolutely agree. And, we're within this Forever Green initiative, we kind of look to Kernza as being sort of the leading path leader in this whole enterprise. And, as I kind of alluded to there, they've really had to deal with those challenges where, there were growers ready to produce a crop because they're excited about the potential that they see. But there's no necessarily, we don't know where that product is going to go. And likewise, we had the situation where we had large food companies say, well, we're ready to do this, but we don't have the acres ready to plant. So it's a very challenging balancing act because you don't want it to fail, right? You don't want to have farmers producing a whole bunch of this grain and then not making any money off of it. So that's one of the reasons I think that the breeding and the agronomy efforts really has to be paired with a commercialization team. And that's one of the things I think that the Forever Green Initiative has been innovative about, is really hiring people who are specifically thinking about that commercialization scheme and how to de-risk things for farmers. So many of the farmers that are growing Kernza right now, we've sort of almost created kind of a crop insurance program for them, through the grants and the financial support of that research.
There you go. I kind of agree entirely what he said. We were hitting that wall several times. We were having meeting with farmers for some of these PE project, and we have the agronomy, we have the germoplasm. But the question was, okay, what we do with the grain? So if you don't have the market, you are facing a hard time making these systems evolve. So short comment is that, yeah, if you don't have the market, you don't have anything there. So.
Oh, sorry. Let me use that one. Okay, thank you. Sorry about that. So on the nutritional quality side of things, tremendous credit to Harvest Plus, which is an organization that has been focused. I showed a paper from Howdy Buison and team. They have done tremendous work in biofortification, or the improvement of crop nutritional quality through breeding indoor agronomy. So they have done really important studies with regards to impact, like do these biofortified varieties actually improve nutrition? Our group has been working as well on carrying that nutrition through to time of consumption, all the way to the end of that supply and demand stream. A couple of things I thought to mention from Harvest Plus. In the case of our provitamin A dense maize and several carotenoids, Turns out that there were examinations, there had been aversions to yellow maize for various reasons in certain parts of the environments in which provitamin A maize was being developed. And it was found that orange maize was actually viewed as distinct and novel compared to yellow maize. So in that case, it kind of became a unique product that then started to have its own demand, and then seed systems and scaling up and kind of moving varieties around regionally and then developing ones that were really adapted to the endemic stressors ended up being really critical. So seed systems has been absolutely critical. I also thought to mention in the orange flesh sweet potato, Jan Lowen team, and I know there's people here who work on sweet potato, really did pair the breeding and the agronomy, as you mentioned, and brought about kind of these tandem improvements that brought multi-added value into that system. And finally, I thought to mention, I was just talking about this with actually Karen Sitchy, who's out there as well. This plant science and food science, at some point plants become food. So it really makes a lot of sense, or beverage, or fiber, or fuel, et cetera. So in some sense, it really makes sense for us to be partnering with food scientists who are making the actual products. And I think that's part of how we generate value as well, in terms of like, what are we turning these things into?
That's a great point. VK, do you have anything you want to add?
Yeah, I would just, pick up on where, about the foods part. And I think the connection to the consumer is the most important. I think we are at a pivotal point of time in our path, I would say, if I would, on sustainability benefits, right? We would be doing a disservice actually to the planet if we don't connect this to the end consumer, because this is actually one of the most important things that we need to be able to do, and we have historically not been able to do that really well. And I think so there is a lot for us to learn from the past and make that connection and really bring that consumer into the picture, so that the choices made by the consumer are going to have an impact on how sustainable we are in this world, right? So, and then there will come the value, there'll come the closed chain supply, loops, and then you will see that the farmers will start to get paid for some of these benefits, and that's what's really going to drive some of these practices. So I think we really need to evolve our systems in such a way that it's no longer just a push, but it's really a pull from the end consumer to do this.
Excellent.
I wonder if you have thought about the potential need or benefit from changes in public policy, and whether you're engaging with policymakers or those with expertise in public policy.
I would maybe we are heavily engaged as an organization. We actually have a huge set of people and team, dedicated to work in the space of policy, because that has a huge impact, and we've seen that as an organization. We've learned it, when we did try to bring in, GM traits, right? And now with the European Green Deal, there is another big challenge that we have. So unless we actually work very closely with the public policy makers, this is simply not going to be, getting us to where we really need to be. I mean, the European Green Deal is a challenge in a sense that it's actually going to take us backwards in terms of innovation to meet the needs. So extremely important, yes.
A short example. So in New York State, there was an initiative to give brewers a tax break if they use locally produced ingredients. And that really incentivized the breeder in that state to develop winter barley as a new crop in New York, and also stimulated the growth of small craft brewers and craft maltsters as well. And so, that's an example of a policy that can actually shift, not just the agricultural production system, but also the downstream supply chain as well.
So again, in the nutritional quality space, there is relevant precedent in terms of food fortification programs. So in terms of adding a premixed formulation of nutrients in, say, the processing stage of a crop. So iodine in our salt would be an example, or adding, say, zinc to flour, etc. The nice thing about fortification in that stage is you can add a premixed formulation of nutrients. So instead of having to breed in several separate nutritional traits, we can drop some of them in altogether. So that's nice. However, there have been findings that regular transportation still becomes really important for that type of intervention or solution to actually have impact. So I do think in the terms of government policy, there is precedent in those food fortifications, some of which have been, there have been policies made by federal governments. I do think for the biofortification, we need to really make sure that we've well characterized stability in G by E so that we know what consistently is being provided out of this biological system rather than some kind of chemical formulation. Also, I'll mention in some of the work in Southeast India, there had been a price ceiling placed on certain varieties and a lottery for certain seed, which would not always be sufficient for a farmer's full operation, but they would be eligible for a certain quantity of seed. So that was a really interesting and different model that had really concrete impacts. So it's interesting to see some of these. I'm not an expert in policy, but those are a couple of the interfaces that we've seen and had. And again, Harvest Plus is doing great work in this space, I would say.
Just a quick comment in terms of policy. I think that is a critical component of this type of cropping system where we have a dual purpose, that is food and also an ecosystem services. And one of the plots that I showed there where you have a yield penalty of using the cover crop, but you have an ecosystem service benefit, right? So in that sense, I think that policy will help us to say, okay, who's going to pay that yield drag, or who's going to pay for that ecosystem services? And I think that in that space, policy is the key.
I have two questions, one for Christine and one for Kevin, but regarding crop growth models and whole genome prediction, and the slide where you had the comment, it's as good or better. And so as you think about the future and increasing the resolution, the variables that go into the crop growth model, what are some of your predictions on how good do you have to get to convince every plant breeder to use it? It's just that good, it's undeniable. And then, well, I know you got an answer for that, but Kevin, on your slide with all of the lists of potential cover crop, and you had hazelnut and woody perennials, so I'd like to hear why those are on the slide in particular. But Christine first maybe, and then.
Yeah, so you know, as I was saying, this Forever Green, oh, sorry. I'll go first. So the Forever Green Initiative is really it's sort of a consortium of projects that were already in place. So there was a hazelnut breeding program in place, and they sort of naturally became part of it. And then, you know, it sort of grew organically. I mean, it started with a few projects, and then as the goal became clear to other people, they saw how they fit into that goal, and then they sort of became added into that project. So that's how we came up with this sort of diverse collection. It wasn't any sort of pre-thought out process. Yeah.
And then great question in terms of how good does this model need to be a method. I would say moving this from like the R&D to the production has been it's a really interesting process because it does take additional data streams to parameterize these CGMs. So for instance, it really is helpful to have observed data on soil properties. And there are experts in the team that we were working with at the time who could get that for us, even down pretty deep in the profile. Our team has switched to some extent. We're still working some with mechanistic CGMs, like on a daily timescale, et cetera, some submodules on an hourly timescale. We have switched as well to more like 3D biophysical models and training those directly from sensor data. So that's been, in some ways, maybe a more flexible framework in which we can work that may not require a super, I mean, it ends up you work with engineers, you work with physiologists all around in both of these frameworks. But I guess that would be a matter of like what percentage improvement is worthwhile to like switch a whole process over within whatever your breeding operation is. And does it take dedicated personnel? Is there something we can help train each other on and build into the methods toolkit that each of us are using? So not a super concrete answer, but I've been seeing enough of a gain that we're continuing to do it if that's the case. And every breeder, if you're interested, I'm more than glad to talk with you. But there's so many scientific and logistical reasons why it takes a lot of extra work to implement at this point. And that's part of what we're moving towards, is being able to intake some of the more standard data that each of us are generating in our breeding programs and work with models from there. It does help to measure priors on, say, like parents of a population. I don't know if Charlie Messina will talk about this or not later. But sometimes on a subset of individuals, we can collect more intensive information that then helps us fit the population effectively.
It was not included in the question, but can I answer that?
Yeah, please. I was just going to ask if anybody else wanted to add on to the crop.
No,
growth model.
just a quick comment about, you asked about the future, and I think that we are doing a lot of high throughput phenotyping. And I'm not sure that we are using that data as much as we can, and I think that the connection between, because when Christine mentioned about priors and, okay, you go and measure biomass or leaf area or flowering time or even yield. Those are very hard traits to measure. But I think that there is a missing connection between all the high throughput data that we are collecting and the crop modeling effort in terms of maybe defining priors based on the data that we are collecting massively.
BK, do you have anything? Sorry, I don't want to leave you out.
Yeah, I think the breeder in me, screaming to say that the heritability of these traits, is so low, right? So that your best chance really to address them is actually with the marker effects. So, I don't really see us making a lot of progress purely based on phenotypic selections. Rather, you would have to definitely integrate a combination of both the markers and the phenotypic, primarily because these traits are so difficult. And so I think we have the tools. I actually don't see a problem for the plant breeders to actually incorporate them. It's actually going to benefit them a lot by doing that and make progress quicker than what we would be able to do just purely with pure phenotypic data.
No. One thing that in our programs that as we look at this idea and how to incorporate it, well, I don't know, maybe it's just us, but there might be others that can sympathize with this, that we just have to set up our data process in a different way and be able to track the data, have the right master data, metadata that goes with each plot so that you can attach some of these other sources of data to it. We're far too simplistic in how we're doing our work, and as we think about this, we're learning that, okay, we really need to think about this differently and be more thoughtful in how our breeding process collects data and so that we can attach other sources of data to that, whether it be climate or other parts of the modeling process.
I want to just follow up on the points quickly with these relatively low heritability. This is part of what I'm going with the emergent properties. If we can model the more full set of G by E by M main interaction, heritability is not really an upper limit anymore. We're still really focused on increased accuracy in predicting breeding values. But when we're predicting into tested and untested environments, it's really nice to be able to capture that additional variance, has been our finding.
There's a question in the back.
Yeah. Well, first, thank you all for your talks. So, like you mentioned, obviously, adoption of these is critical. We can come up with something awesome, and then if no one adopts it, it doesn't matter. And I know that with current cover crop systems, a major barrier to adoption is that it requires more labor and trips through the field, specifically at the busiest times of year in the spring and fall, or at the beginning and end of the growing season when there's so much to do for the main crop. So I was thinking that particularly the double cropping systems might have some of the similar issues, even if it's not that busiest time, just more trips through the field, if nothing else, more fuel, compaction. So I guess how are you addressing things like that in conservation practices? Is that engineers, is that breeders, and how are you involving farmers in that conversation?
I can start. No, that's a really great point. I think that there are many different options to address all those issues, but of course, if you want to have another crop, you will have to do more work, more travel to the field, more operation. There is no escape to that. But at the end of the day, I think that we need to look at the system in terms of we are doing some work on life cycle analysis, for example, to evaluate exactly those things that you're mentioning. Okay, so we cannot escape to go more time to the field, but we need to be sure that we are not doing any harm. We want to be sure that all that extra energy that we are investing in the system is being well used. So I think that I don't have the answer to that. I mean, you need to go more time to the field, that's for sure. At least you have like perennial ground cover or other type of systems. But I think the answer is on, okay, let's see the whole system, do a life cycle analysis where you go from the energy that you are inputting and what is the outcome. And that way you can do a true evaluation, because you can go more times to the field, but you may be fixing a lot of carbon and the balance will still be beneficial. So, yeah.
Yes, I would agree. I would agree with that. I mean, we're sort of at the very early stages, so all I would say is that we just need to do a really good job of measuring all of those inputs and outputs. And then hopefully, you know, I'm already way outside of my area of expertise as a plant breeder trying to do some of these things, but my goal is to try to create enough data to make it compelling enough for other people to say, okay, well, what's the next step, and sort of really trying to figure out how the system works. But then I think another point you raised was getting input from growers, and I think that's a really important thing to do as well. And so far, it's really just been sort of anecdotal. I mean, I'll show these plots to growers, and then they'll come up to me and talk to me later and say, well, you know, why this will never work, or why it might work. But I think a really more formal way of getting that kind of input would be really critical. It's a good point.
BK, do you have anything you'd like to add?
No, I just second the part
Okay.
that's saying that life cycle analysis is important.
Yes, we're right in the middle of that process at Driscoll's, going through each of our production systems and doing that type of analysis. It's really interesting. Most of our footprint is in the grower fields. Not surprisingly, and so yeah, there's going to be a lot of conversations and talking with growers for them to understand what the benefit of making some of these changes to their systems would be based on the life cycle analyses that we're doing as well. All right, well, we're at 9:30 and we'll wrap it up here.
Rick?
I want to thank...
Rick, may I have a comment, please?
Okay, sure. Yeah,
Okay,
Ksenia.
I did not think I would make a comment because I'm minority in this conversation. But I'm glad I saw specialty crop on your list as a hazelnut, because this is something that people in the specialty crops are trying to do already. Because there's long period after you plant the orchard till you actually harvest it in a certain crops. So we intercrop walnuts with apricots. Just because by the time the walnuts start producing, apricots are almost done. And so maybe some type of intercrossing with seed crops and specialty crops, perennial tree crops, could be also a potential solution for the growers to just keep some income coming in until you actually wait for the production to start on the specialty crops. Thank you.
Thanks, Ksenia. Yep, yeah. Is that on? Yep.
This is the SK Kim. I came from South Korea. I'm probably only person from outside. He's the only person to hair because I don't have much hair. So I had I have the two questions. First, the Christine. So you said you stayed researched in Zimbabwe, certain period. I'd like to know what is the key breeding target under climate change from Africa and the U.S. My second question is the last speaker. That's in case of Korea, the overproduction of rice is very, very serious. So this kind of the rotation and cover crop. Like the as you made the soybean, and barley in U.S. and also, but in case of Korea, attract the tourist. Some farmers have much higher income than their own crop production. So here is like the sunflowers. Because of the Ukraine war, Russia attacked, and the sunflower can be very attractive to attract tourists. So I'd like to know your breeding target. This kind of attract the tourists. In case of farmers, is very, very important. So farmers their major key interest is increased income.
Yeah, okay.
So,
Thank you.
Thank you.
Thank you. Does anybody want to take a quick stab at that? Then we'll have to cut it off for our break.
Sure, I'll go as fast as I can. So
Yep.
in Zimbabwe, we were largely still focused on provitamin A and also drought and high temperature tolerance. So there were issues such as tassel blast that we were working to amend. I would say also there was need for improvement at the hybrid and inbred level. So seed production was really an issue with some of the varieties being brought in regionally. So we were looking at both of those levels in that regard. In the US, I would say, this is just an example on carotenoid dense maize. We're also looking at lutein and zeaxanthin, which are on average the two most abundant carotenoid compounds in maize grain. There's been increasing evidence that elevated dietary intake of those can be helpful in reducing risk of age-related macular degeneration, which is the leading cause of vision loss in adults above a certain age. So it turns out that we can, it looks like, and Mary Francis from our lab in this room has done great work on improving provitamin A, lutein, zeaxanthin, and then also in the US and to some extent in Zimbabwe and Mexico as well, going for bright orange kernel color, again because of that novelty and distinctness compared to yellow maize. So we've got the kernel color and then the multiple nutritional improvement in there.
The tourist question. So one thing that I've thought about in the case of barley and potential double cropping systems with barley is really engaging the craft brewing industry and those tap rooms. And I've written into several grants that unfortunately haven't been funded to try to utilize these tap rooms that are developing all over cities, all over the place, as vehicles for outreach about agriculture and about where your food comes from. Because I think, that's an audience that could be very receptive to that sort of thing. And so I don't know if it relates directly to your question about tourists, but it's a way to engage consumers more directly with where their food or where their beer comes from in a way that I think could be really effective. So we've tried a little bit of that on our own, but I would really love to expand on that.
All right, I think we'll cut it off there. But thanks everybody for your time. I just want to say a couple things that I think that I really resonated with me was collaboration. Let's all reach out and collaborate. I think I have a lot to learn in that area and my company. And this is like inspirational I think it's a great topic for that to happen for us. And also thinking about these things from end to end, the whole thing, the whole chain. It's not just about the breeder and the grower, it's about the whole chain. And sometimes we just got to step back and think about the whole value of what we're creating. And so maybe those are a couple of things we can take away and build on. So thanks everybody.
Thank you.